you're changing, because you're changing together, it doesn't change.
All right. So yesterday we talked about the product rule. So just a reminder, the product rule is the derivative of u times v is u v prime plus v u prime, where u and v are functions of x. That's the product rule. That's what we talked about yesterday. Any questions about that? Okay, so today we're going to talk about the quotient rule. Which, again, the normal sum difference rule doesn't work. The derivative of u over v does not equal u prime over v prime. That definitely doesn't work. And here's proof of that really quickly. Like suppose I have the derivative of x to the fifth over x squared, or something like that. That's easily simplifiable. Like I know that this is equal to the derivative of the simplified version of this, which would be x cubed, which is 3x squared. However, if I try and use this thing here that doesn't work, I get 5x to the fourth over 2x, which simplifies to be 5 halves x cubed, which is 100% not equal to 3x squared, right? They're totally different. So this is the correct answer. 3x squared is the correct answer here, the correct derivative. This is the wrong way to do it. This doesn't work, okay? So this, just to summarize, like this type of rule works for addition, it works for subtraction, but it doesn't work for multiplication or division, okay? That's kind of the summary you need to remember. So the quotient rule, what the quotient rule actually says is the derivative of u over v, and again, u and v are any functions of x, is equal to v u prime minus u v prime over v squared. Okay, so the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So let's just verify it using this example that we just did, just to verify that it works. So the derivative of x to the fifth over x squared, according to this quotient rule, should be the bottom unchanged times derivative of the top, 5x to the fourth, minus top unchanged times the derivative of the bottom, which is 2x, over the bottom squared, which if you square x squared, you get x to the fourth. So this ends up being 5x to the sixth minus 2x to the sixth over x to the fourth. So this is 3x to the sixth over x to the fourth, which simplifies when you subtract exponents to be 3x squared. And that's exactly what we got up here, 3x squared. But again, don't get stuck on like, well, why didn't we just do it that way every time? Because there's going to be certain types of functions that you can't avoid using this process. Okay? Some people have a hard time like memorizing this. Obviously, you don't have to memorize it, but if you take any other math class ever again, you will have to memorize it. So I'll show you how I remember it in my brain. It might be stupid, but it helps me. So I just remember that this is like the high term, and this is the low term, right? We have high and low. And then I just remember low d high minus high d low all over the bottom squared we go. And it could be like a song, maybe a country song, probably.
No, isn't it like the song with like the 7 dwarfs or something?
What?
The 7 dwarfs or something have a song like that.
Do they?
Yeah, like
Oh,
that.
hi-ho, yeah. Yeah, that doesn't work. But I know what you mean. So that's honestly like what I think to myself every time I have to do one of these. Low D high minus high D low, all over the bottom squared we go. Okay? So the functions might be more complicated, of course. Like you might have something like a polynomial divided by a polynomial. Like it might be 5x squared minus 2x plus 1 over 3x plus 4. Something like that. So this derivative, y prime, would be the bottom, unchanged, 3x plus 4, times the derivative of the top, 10x minus 2, minus the top, 5x squared minus 2x plus 1, times the derivative of the bottom. What's the derivative of the bottom? Just 3.
Right.
Over the bottom squared. And that's the answer. A great question. No. Delta math is weird about this. It says simplify your answer. So here's what they mean by simplify your answer in delta math. They mean the numerator, they want you to like FOIL everything out and combine like terms. The bottom, you can leave it just like that. You don't have to like FOIL that out. So that's what they want you to do. So in this case, you would FOIL this out so you get 30x squared minus 6x plus 40x minus 8. And then here I want to distribute a 3 and also a negative. So I'm going to distribute negative 3. So I'm going to get minus 15x squared plus 6x minus 3. And then they just want you to combine all the like terms. So if I combine all the squared terms, I have 30x squared minus 15x squared, which is 15x squared. Negative 6x plus 6x. Oh, that's nice. They cancel. And then plus 40x. So that's just plus 40x. And then the constants, I have 8, negative 8 minus 3 is negative 11 over 3x plus 4 squared. So this is how they want you to leave it in delta math. I know it's a pain, but that's what they want. And actually, this one is probably a little bit more complicated in terms of like, I don't think I saw any problems on delta math that were trinomials in the numerator, so, or the denominator. So that makes it a little bit easier too. You could also have a function that has a quotient involving trig functions. Like you could have something like y equals maybe like cotangent x over 5x to the 4th power. And this would still work. So dy dx is the bottom, 5x to the 4th, times the derivative of cotangent, which if you remember is negative cosecant squared x, minus the top, times the derivative of the bottom, 20x cubed, over the bottom squared. Now remember, if you were to simplify this bottom, which I'm not going to, but if you were going to, you would have to square the 5 as well as this. So this would end up simplifying to be 25x to the 8th, right? Because you multiply the exponents, taking powers of powers. Any questions about that? Low D high minus high D low, all over the bottom squared we go. Any questions? Want me to do another one, or you feel okay? Good, I'm glad. So just a reminder, I'm not going to be here tomorrow, so make sure that you have something to do. It's just going to be a free day. I'm not giving you anything to give you. And then Monday, we'll just pick up where we left off here. New material, Monday, Tuesday, Wednesday. Then, actually, no, Wednesday is actually going to be a free day. You know, it's a 5-day week. And then, so Monday, Tuesday, and then Thursday, test review. Friday is your final exam. But it's only worth the normal test. Any questions? Okay. Let's stop recording then.